Standard number 3, similar shapes. The first test we took in this quarter were congruent triangles. Congruent means that all the angles are exactly the same and all the sides are exactly the same. Similar only means that the angles are exactly the same. The sides are not exactly the same. However, the sides do have something special about them, and that's that they are proportional. Sides are proportional. Essentially, what we're doing is we're dilating a shape. Remember back in congruent, I told you that AAA does not work. AAA was a no because you could have a little teeny tiny triangle that say was equilateral, or you could have a bigger one. They could both be equilateral triangles. An equilateral triangle doesn't have to be any particular size. Both those triangles all have 60-degree angles. They're similar to each other. They're just not congruent. One is bigger than the other one because one got dilated. And either the small one got dilated into a bigger one or the bigger one got shrunk, dilated down into a smaller one. The sides, however, are proportional, which means they have the same ratio, which means the whole triangle changed by the same scale factor. So there's another vocab term. Scale factor just describes what the rate of proportionality is. It tells you how much bigger or smaller a shape got. Let me give you an example and see if any of this will start to make sense. Here's a triangle for you. It's a right triangle. Here's another right triangle. It happens to be where this angle up here is 40 degrees, this one's 50 degrees, and those match up to these. Those are also 40 and 50 over there. The only reason I didn't write 40 and 50 is because I don't have enough room, so I wrote the little marks. So they're congruent. Those are both 40. These are both 50. These are both 90. Those are similar triangles. To be similar, they have to have the same angle measures. So they have the same angle measures. They're similar. Now, because they're similar, we know that the sides are going to be proportional. This triangle got a certain amount bigger. Say it got twice as big, then all of these sides are twice as big as these sides here. So let me just show you an example of that. Let's say this side is 6, this side is 3, and this side is 8. Which if you do Pythagorean theorem, that's not going to work out, but don't check me on that. All right, and let's say the scale factor is 2. 2 means that it got bigger. If the scale factor was equal to 1, that would mean it stayed the exact same size because you multiply these numbers by the scale factor. So 6 times 1 is 6. That means that side didn't change size if the scale factor is 1. If the scale factor is less than 1, say 1/2, then you shrank. It got smaller because now you're multiplying by something less than 1. Your number gets smaller. If you're multiplying by something greater than 1, your number gets bigger. So I'll talk about that more or reiterate that probably every day, but that's an important fact with scale factor. If the scale factor is less than 1, you're shrinking the shape. If the scale factor is bigger than 1, you're blowing up the shape. You're expanding it. You're making it bigger. Okay, the scale factor is 2, so what's this side going to be? It's going to be 12. What's the bottom going to be? It's going to be 6. What's this side going to be? It's going to be 16. Yes, it is kind of that simple. You just multiply these numbers by the scale factor. Sometimes it's a little tougher when they don't give you the scale factor. They might give you something like this, a rectangle, and then another rectangle over here. So not only did this rectangle get bigger, it also rotated. So now it's a little trickier to see which side matches up with which. They're also not giving you the scale factor. They might give you something like this. This is 4 and this is 10. And this side is 25. And then they'll ask you, what is x? What is that length right there? Now all of a sudden we've got a real problem on our hands here. This isn't so simple anymore. And the way you do this is you have to figure out the scale factor for yourself, basically. You got to say, how much bigger did this rectangle get? Well, did it go from 4 to 25 or did it go from 10 to 25? You're just going to have to look at the picture and see if it's rotated or not. This is clearly rotated, so you'd have to rotate this, and then the 10 would match up with the 25. Some of you might be saying, no, the 10 would be up here if you rotated it, which is true. The 10 would be up here, but it's a rectangle and opposite sides are the same. So if the 10 goes up here, that would actually be this side here, so it'd be the same. So the 10 goes to the 25, so it got 2.5 times bigger. This rectangle is 2.5 times bigger than that. If you thought the 4 went to the 25, you might say that's over 6 times bigger. And then that would throw off your calculation. So you got to match up the correct sides. Another way to match up the correct sides is sometimes they'll tell you the letters of the rectangle of both of them, and then you match up the letters like you did with a triangle. So let's say this is E, F, G, H. They might tell you that A, B, C, D is similar. That's another, it's not really vocabulary, but symbol. This is an equal sign. This is a similar sign. If you put them together, you get congruent. So just the little squiggle means similar. So they might tell you that ABCD is similar to F, E, H, G. If you have that, then they're telling you which sides match up to each other because the order matters, just like the order mattered in a triangle. The first 2 letters, that's going to be a side, is going to match up with those first 2 letters. So AB is going to match up with FE. Same with you're just looking at angles. In this case, it's a rectangle, so everything's 90 degrees. But if it's like a triangle and you're not sure what angle matches up with what angle, you could just look at the one letter at a time. Angle A is going to match up with angle F. Angle B is going to match up with angle E. So you just have to look at one letter for angles, but 2 letters for sides. So BC and EF. BC is right here. EF is right there. Those sides are going to match up. So that's another way to tell what matches up. All right, so how do we figure out what X is? Well, how do you get from 10 to 25? From 10 to 25, you multiply it by 2.5. So you multiply 4 times 2.5, and you get 10. So this X is 10. All right, I kind of did that in my head. So how they're going to show you how to do this in the book is to set up fractions. They're going to say 10 went to 25, so they're going to do 10 to 25. And that's equal to the same ratio of 4 going to what? X. And then you can cross multiply and divide. 10 times X is 10X. 4 times 25 is 100. Divide by 10, X is equal to 10. So that's another way to get 10. That's probably the recommended way to do this because we're going to have to keep doing that when we get into the next standard of more in-depth similarity. So you might want to get in a habit of doing that. Another thing is this gives you a little bit of freedom. You could also set up your fractions in the same problem. So you could say 10 to 4 is equal to long side to short side. You could go long side to short side, 25 to X. So if you're going in the same same shape, you just have to go in the same order over here. If you go long to short, if you go AD to AB, then you have to go FG to FE. Long to short, FG to FE. And then you can cross multiply, get 10x is equal to 100. You get the same thing. So if you're using the fraction method, it gives you a little bit more freedom. If you're just looking at it and you can figure out in your head how many times bigger this is, you don't necessarily have to do it in your head. You could say, what do I multiply 10 by to make it 25? would be 10x is equal to, well, I'll say 10s for scale factor. 10 times what is equal to 25. You divide by 10, and your scale factor is 2.5. So you can figure out the scale factor that way. So you have a few different options on how to solve these problems.